Hello everyone, my name is Cheng Shuoxia from Keio University. I'd like to give the presentation of this paper, VoLearn, a cross-modal operable motion learning system combined with the virtual avatar and auditory feedback, collaborate with the Carnegie Mellon University. I think that everybody has experience to conduct a motion exercise. When we want to learn motion, we normally search for video tutorial online, watch the video, and imitate the exercise. However, we definitely doubt that I conduct the motion correctly or not. Is there anything wrong? This would frequently happen when we study or training the motion by ourselves without a teacher or a coach. Another issue is that normally the studied motion is very uniform. However, everyone has different behavior, manner, and physical conditions. Like children and elderly cannot afford too extensive exercise, and for stronger people, their motion requirements should be more strict. Thus, the uniform motion for learning cannot satisfy different individuals. Therefore, we are going to solve the issue that makes more individuals can have customized motion learning or training process. Meanwhile, the user can also have effective real-time feedback to improve their behavior. Extensive existing works has already concentrated on the motion learning tutorial. For example, the recent commercial product, the exercise mirror, could allow the user to follow the subject in the mirror and conduct the motion. The most popular guiding method relies on the vision method, that requires the user to stare at the monitor to see any possible difference between the reference motion and their behavior. To enable effective feedback, the arrow-based method typically helps the user improve their performance, and uses different modalities to provide improvement instruction or evaluation result to the users, such as the score and the emoji. While in this paper, we proposed VoLearn, a cross-modal motion learning system that allows the customized motion learning or training process with the auditory feedback. It consists of three main parts. The user can edit the 3D motion in a customized way for learning, which is registered from the 2D video, and the system can analyze each body limb's movement and generate the reference motion data and sensor placement for learning. In the real world, the user only needs to attach the personal smartphone to the specified body part and can receive auditory feedback to get the behavior. Comparing the VoLearn with other commercial products and related systems, it is clear that VoLearn is a more comprehensive system that can use the daily motion capture device and allow the wider motion registration function and the motion modification function. In terms of the system design, at the first, we convert the 2D video into 3D motion. The user can upload their motion videos and then enter the local library. And the user can select the interesting motion for further addition. Like the user can adjust the motion, make it slower or quicker. The user can adjust the views to see the motion and adjust the motion's amplitude by different exercise, or small movement or large movement. They can also select different limbs to adjust the motion amplitude. The system provides a combination function to combine the different exercises together, like the upper limbs doing the extending chest and lower limbs doing the squatting, and also can set the frequency of different combinations. After the motion is designed, the system can analyze the motion and generate the After the motion was designed, the system would analyze each body's limbs movement and select the maximum motion velocity at smartphone's placement. To better fit the real rotation data to the virtual reference data, 3 parts need to be adapted, including the varying position, sensor coordinate, and sampling rate. Here is an illustration of mapping the virtual smartphone coordinate into the real smartphone coordinate. And at the user end, we design an application on the user's smartphone to generate auditory feedback to compare the user's practical motion data with reference motion data. As you can hear, when the user is approaching the correct position, the auditory feedback increases. Once the user reaches the correct position, the application will generate the bingo-like sound to remind the user approach the correct position. And after the user completes the motion and go back to the initial position, the system will analyze the user's behavior and give back the improvement advice, like excellent, good speed. And you can just also make the motion faster. In the real world, users have to do the faster. Or make the motion more deeper.
Excellent. Good speed.
We conducted 3 experiments to evaluate the Proposity system. The first experiment was conducted to test the initial error between the generated virtual motion data and the important real motion data, to see how much the error will be during the system processing. We selected 10 exercise motion and tested the motion data error of the dedicated body lengths calculated from the system. From the result, the 2D video to 3D motion conversion normally did not change the motion very much, and did not alter the motion's basic movement. Secondly, to validate the feedback effectiveness, we conduct a user study to see how auditory feedback can help the user study motion. We define 2 main scenarios. The first one is the user used auditory feedback and 3D motion during the learning phase, and when they show the motion, they only used auditory feedback. The other case is that the user used the auditory feedback and 3D motion during the learning phase, and then we closed the auditory feedback in the 3D motion when they showed the learning results. We have the total of 20 participants who joined the experiment. We made 3 hypotheses: that feedback can reduce the motion amplitude error and time error in both scenarios, and is more effective for complex motion study. We picked up 6 motions from the first experiment for participants to learn. The results showed that the system could effectively reduce the amplitude and time error, but did not show a significant effect on complex motion learning. An additional auditory feedback did not increase the cognitive load compared with only watching the monitor. And basically, all the users have a good commands on the system, such as the feedback motivating them and giving them the goal to learn. The third experiment was conducted for the professional users who have the knowledge to design a customized motion. The first one is a gym coach. He thought that the system is helpful for the remote learning, and he can design a motion for the student, but he wants more limbs can be tracked. The second one is a clinical nurse. She said that it will help the patient, especially for laying on the bed, but she also wants a standard motion laboratory for them to use. The last one is a therapist. She thought that the system can release the burden and better for the remote learning for the patient. So far, the system is better to be used as a support tool that has a big prerequisite that the user should be familiar with the motion. And as each user normally has only one smartphone, the system could only support tracking one body limb. So for the future work, it can focus on a higher performance 3D motion reconstruction and develop the comprehensive motion addition interface to design the motion more fine-tuned, and study the longer effective of the using VoLearn is also the focus. This is a summary of the project. We proposed VoLearn, which is a cross-modal motion learning system combined with a virtual avatar and auditory feedback. It can help the user to reduce the amplitude and speed error during the learning. Thank you very much.